Unit 7, part 14, okay? We're after this by conditional. We figured out we're going to get it by modus ponens. We need to derive this conjunction, right? We need the antecedent of this conditional to get that, okay? It is a conjunction. That makes me think, right, that's working backwards. This is my interim conclusion. That's what I need to get home, right? Just that formula, that conjunction. Okay, what rule allows me to infer conjunctions as a conclusion? That is, what rule has as its conclusion formulas of the form conjunction? Only conjunction does, right? So I'm going to get this by conj, and knowing that that's the rule I need, I know what form my premises have to have, and I know what particular formulas I need, what premises I need to make the conjunction, to perform that rule. To do this conjunction, I need this separately and that separately. A or B by itself, and not A or not B by itself. And if I get those two, that's the conditions for the rule of conjunction. I now have the two premises of the rule of conj satisfied, and I can perform this conjunction, then I can do my modus ponens and get my conclusion. Okay, so I need to get that, and I need to get that. That's my thought. Okay, where are these going to come from? Well, it's crucial you're able to, when presented with a proof, analyze the structure of your premises, right? Look at the premises, look at what form they have, and ask yourself, what rules apply to formulas of this form, right? And quite often, with a lot of problems, there are some automatic things, there are some basic top-down things you should do, basic automatic things you should do, some habits you should get into. For example, as I've said, whenever you see a conjunction, you should simplify. So you need to be able to see that premise 1 is a conjunction, right? It's a big, long, ugly, horrible formula, but only attend to the question, what is its form? What is its major operator? It is a conjunction, right? So it's crucial that you are able to look at premise 1 and ignore all its complexity and just see a P and Q. Right? That's what this is. This is a P and Q. And if you have a P and Q, you have the premise for simplification. Okay? So, and whenever you've got that, whenever you've got a conjunction like that, you should be habit, you just simplify both conjuncts, right? So I've got A, hook C, and now this one, not A, hook, brackets, not A or not B, I know over here. Okay, so I got that from 1, simp, 1, simp. Okay, and you should look at 3. What do you see when you look at 3? What you should see is, again, a P and Q, right? Well, what is the form of 3? Is 3 a negation? No, it is not. What is being negated with that first opening negation sign, right? Cover up this. Remember, right-hand rule, the first legal formula you uncover is what is negated. So open brackets, it's not a legal formula until I close that bracket. F or A, not a legal formula yet. Close brackets, okay. That's a legal formula. That's what's being negated. So you have to be able to see in an instant that this formula is a conjunction of not F or A, not F or A, it's a conjunction of that and A or B, right? So the conjunction is the major operator. So it's a conjunction, so you simplify, right? So 7 and 8, right? Notice it's 2 steps. I'm deriving 2 conclusions, right? Each conjunct. Not F or A, and A or B. Okay, now let me stop and take stock and think where I am. What did I need? I needed these two, right? I needed this conjunction. So I just need to get this by itself and this by itself. I've just got this one by itself, right? Just by simplifying 3, all I needed to do was recognize that that's a conjunction, simplify it, and now I have that. I'm halfway home. Getting home involves getting these two parts, these two things, conjoining them, doing the modus ponens to that which is my actual conclusion. Right? Okay, so now just say what remains to be done. What else do I need to get? And of course it's just this. Okay? Notice that this appears, right, here in the first premise, so, and that now has been simplified to this, okay? And this, it appears here, the thing I need appears here as what? As the consequent of a conditional, right? It appears as the consequent of the conditional, which means I can get that by modus ponens if what? If I have the antecedent of the conditional. So if I can get not A, I am home, right? Just notice as an aside that if you had not A, you could also get this without this formula just by addition. If I had not A, I could derive from it not A or not B by addition. Right? But also you can do a modus ponens with this. So now my question becomes, I'm working backwards, I'm seeing what I need to get home. Now I just need to get not A, where's it going to come from? Okay, so remember the thought you use on conclusions. For any formula you need, like for example a conclusion, you ask yourself, where does that formula plus or minus a negation appear amongst the premises? And the plus or minus negation part is added especially for potential modus tollenses, right? Because here we said we want not A. Here we see that A appears as the antecedent of a conditional, okay? Which means if I can get, did I? Oh, yeah, okay. Which means if I can get, right, if I can get not C, right, if I can get not C, then I get not A, right? I need not A so that I can get this formula, and then I'm home. How do I get not A? To get not A, what I need is not C, right? Why? Because I'm going to do a modus tollens, right? So I'm thinking that is premise 1, and that will be my conclusion. The thing that I need, not A, is my conclusion of a modus tollens. So what I need is the second premise of modus tollens. What's that? Modus tollens is conditional and negation of the consequent. So I need not C, right? See how when you're figuring out what rule you're going to use to derive what you need, I've identified what I need. I've asked and answered the question what rule I'm going to use to get it from whatever other premises are there. It's usually the first premise of a modus ponens or modus tollens, right? The certain conditional. And then you say, okay, the formula I need to get that is then going to be the second premise of that rule. So here it's the negated consequent, so it's not C. So how do I get not C? Same thought again. Where does C occur, plus or minus a negation amongst my formulas? It occurs here, right? Again, as the antecedent, I would be able to get not C by modus tollens if what? If I fulfill the second premise of modus tollens again, but now in this case it is the negation of this, right? I need the negation of the consequent. Right? C is the consequent here. C is the antecedent here, need not C. So I need the negation of the consequent, so I need not brackets F or A. Oh look, I've got that, right? That appears just when I simplified 3. I got that. So now I'm home free. Now I know how to complete my proof and move on, okay? So continuing on, what do we get? We've got not C. Let's come over here. 7 and 8 will what? Simps of 3, 3, simp, 3, simp. Not C is by 2 and 7 modus tollens. That was to get not A, 10, not A by 9 and 5, right? Modus tollens are 9 and 5. Okay, why did I want not A? I can do modus ponens on 6 and 10. Again, you could also do addition here to get this, but that gets me, I'm doing this modus ponens, not A or not B. All right? Do I have the two conjuncts I need? So now I'm putting, what's this, 8 and 11 together by conj, right? 8 and 11 conj, oh, I've got enough space, but it is, right? A or B and not A or not B. All right, so that should be over here, right here, 8, 11 conj. Okay, and that's it. Now with 4 and 12, so now this is still, I just put a 13 over here, 4, 12 modus ponens. And that's it. That's how you do it, okay? So that was a good example of working backwards in practice.